Tim Harford concluded a column like this. For most of us, the scarce resources in this information war aren't years of study or intellectual brilliance, they are softer assets: curiosity, patience, persistence, and judgment. It is not too late to bring them to the battle. In his column, he was reflecting on some of the characteristics of misinformation. He draws 5 lessons. First, misinformation is often simple, only requiring a misleading caption or context to deceive. Second, emotions heighten misinformation susceptibility. Third, reliable sources like journalists and fact-checkers can help. Fourth, blind disbelief is as harmful as blind belief. And fifth, despite misinformation distractions, we need to focus on the issues that matter. Today, I would like to focus on our ability to find patterns in data and on the effect of emotions in our susceptibility to misinformation. I am Antoine Vernet, and I use social science and data literacy to help you understand business and society. Subscribe for more. Let's dive in. I want to argue that our emotions increase our tendency to fool ourselves that a story is true because we want to believe in it. This happens with any story, not just misinformation. Let me explain. We fool ourselves because we are trained into recognizing patterns, and we see them even when they aren't there. Many people know the saying, correlation is not causation, but we routinely trick ourselves into believing into a causal story about a correlation because that story is nice. Let me give you an example. In a column in May last year, John Murdoch showed a graph with 2 time series, concerns of Britons with immigration and the immigration numbers. He showed that those 2 series tracked each other closely from the 1990s to the Brexit referendum and started diverging sharply after the referendum. This graph used 2 y-axes, one for each of the variables. This is a particularly effective technique to increase the similarities between the 2 time series through scaling. However, in this case, I think it's a particularly effective and justified use of this technique because increasing the similarity between the 2 time series makes it all the more remarkable that they diverge sharply after a while. Murdoch did tweet about some other graphs that didn't make it into the column, and I want to look at one of these graphs in more detail. That graph shows 2 time series again, one about the concerns of Britons about immigration, and the other one about the proportion of Daily Mail articles that are mentioning immigration. Again, he uses 2 y-axes to make his point. In the case of this graph, I think the use of 2 y-axes is potentially misleading because it suggests that it is the Daily Mail coverage that leads to an increase in concern about immigration in the British population. Note that Murdoch doesn't say this either in the column or on Twitter, but I'm pretty sure that many readers concluded that there was some sort of causal link between the Daily Mail coverage and concern about immigration in the population based on reading that graph. I think that's especially likely amongst Financial Times readers that are probably an audience that doesn't like tabloids very much. So, how can we avoid falling for those post hoc rationalizations that our mind comes up with when faced with suggestive evidence? I think we can do this in at least 4 ways. First, we should always be suspicious of figures with 2 y-axes, as it is a well-known technique to increase the similarity between 2 time series. But it doesn't tell us that much about the actual relationship between those 2 variables. Second, we should think carefully about the meaning of the 2 time series and the likely links between them. The case of the Daily Mail coverage and concern about immigration is a particularly good example here because it's easy to come up with plausible explanations like I did above when speculating that it was the coverage that was driving immigration. But another similarly plausible explanation is that it's the concern about immigration in the British population that drives the Daily Mail coverage. Indeed, if British people are concerned about immigration, writing about immigration is a reasonable strategy to sell papers. Third, we can think in terms of implied effect. If the Daily Mail coverage drives concern about immigration, is the size of the effect believable? Daily Mail coverage went from 1.5% of articles talking about immigration in 1995 to about 4% in 2005. That's a multiplication by 2.6. In the same period, concerns about immigrations went to being mentioned by 5% of the population to being mentioned by 30%. That's a six-fold increase. I think it's giving too much credit to the Daily Mail to think that a doubling of the number of articles about immigration would lead to a six-fold increase in concern about immigration in the population. But maybe the reverse story about concern about immigration driving the Daily Mail coverage is more plausible. This brings us to the last point. That second story might be true, but we cannot say for sure that that's the case without a lot of additional context. The correlation could be spurious simply because both series are influenced by other factors. We call those other variables confounding variables. In fact, confounding is the single biggest threat to quantitative analysis. It gives rise to what we call omitted variable bias, which leads us to see a relationship between two variables, not because that true causal relationship exists, but because in fact those two variables are both influenced by a third unmeasured variable. Confounding and omitted variable bias are topics unto themselves, and maybe something I could cover in another video. Let me know in the comments below if you would like to see that. If you are curious about spurious correlation, Tyler Vegan has a great website. I will put a link in the description below. If we take this example, both time series are correlated maybe because they are both depending on population size. One thing we should not do though is fool ourselves to think that those two time series are causally related. To conclude, I hope that you see why this means that critical thinking and data literacy are important skills in order to make good decisions both at work and in life. And that's why I think we should train more and more people in critical thinking and data literacy. I hope you found this useful. Give it a like to help it spread to a wider audience, and check out the video here for more of my content. I'll see you there. Bye for now.